Now it's time for our complex numbers review. First thing we're going to do is simplify some radicals. Remember, when you're simplifying radicals, the first thing you do is make a factor tree. I see we have a negative, so I'm going to factor out a -1 first. Then I'm going to put 72 over here and start factoring that. 72 I know divides by 2, and that leaves me with 36. 2 doesn't divide anymore. 36 divides by 6 and 6. 6 divides by 2 and 3, and it still divides by 2 and 3. Then remember, once you have all of these down to primes, meaning they only divide by themselves and 1, you are going to factor the pairs out of the radical and leave the numbers that are not pairs inside. So I have a 2 and a 2 here, and a 3 and a 3 there. So I'm going to factor my 2 and my 3 out. If you remember, the square root of -1 is I, so this -1 is going to give me an I, and then I still have this 2 under my radical because it doesn't have a pair to come out of the radical with. Then I need to multiply the things that are outside, so I have 6i square roots of 2, and that's going to be my final answer. Same thing over here. I have a -25. I'll make a factor tree. -1, 25. 25 factors into 5 and 5. Those are all primes. I have a couple pairs, so they come out along with my I, and there's nothing left over, so I don't have my radical to write anymore. For 18, same thing, -18, sorry. Factor my negative out. 18 divides by 2 and 9. 2 is prime. 9 divides by 3 and 3. Got a couple pairs of 3's, so I'll factor them out. Remember, the square root of -1 is I, and then I have my lonely 2 left under the radical. -50, again factor out your -1. 50 divides by 5 and 10. 5 is prime. 10 divides by 2 and 5. Both of those are prime, so look for pairs. The 5's are pairs, so I'm going to factor them out. The -1 becomes an I, and then I have my 2 still left in because it didn't have a pair to factor out with. Simplifying here, remember, you combine your like terms. So we've got 6i, -5i, oh, we've got a negative to distribute. So we've got 6i minus 5i, let's distribute that negative. Negative times a negative gives me a +6, and negative times a -3i gives me a +3i. Now remember, when you are writing complex numbers, you always want the real number first and the imaginary number second. So when I look at this, the only real number I have is 6, so that's going to go first. And then I have all these imaginary numbers. 6i minus 5i is going to be 1i. 1i plus 3i is going to give me 4i. So 6 plus 4i. Over here, same thing. I have a negative to distribute here and here. So it's going to be 4 plus 6 plus 8i minus 6i. Again, combine your real parts, 10, and your imaginary parts, 2i. Down here, I don't have anything to distribute, so I'm just going to drop my parentheses because I can't combine anything in those parentheses because those are not like terms. The only real thing I have is -5. Then I have a -i, a 5i, and a 5i, so that would be 10 minus 1, so 9i. Same thing here, don't have anything I can do inside the parentheses, so I'm going to drop them. I don't need to distribute that positive because it's not going to change anything. Combine my real parts, 4 minus 1 is 3. -4i minus 6i gives me -10i. Now we have a little bit of foiling to do. And before we do this, I need to remind you that I squared is -1 because we're going to use that in a moment. First, 4 times -2 gives me -8. Outside, 4 times -3i gives me -12i. Inside, I times -2 is -2i. And then last, I times negative 3 is negative 3i squared. Now I'm going to combine these because they're like terms, and I'm also going to change this I squared to a negative. So negative 8, negative 12i minus 2i is going to give me negative 14i, and then remember that this negative 3, I squared is negative 1, so negative 3 times negative 1 is going to give me a positive 3. Now look, the negative 8 and the 3 are like terms, so when I combine those, I'm going to get negative 5 minus 14i. Got some more foiling to do over here. So first, 1 times negative 4 is negative 4. Outside, 1 times negative 7 is negative 7i. Inside, negative 3i times negative 4 is positive 12i. And last, negative 3i times negative 7i is going to be positive 21i squared. Combine your middle terms because they should be like if the factors were in the form a plus bi. Negative 7 plus 12 is going to give me 5i, and remember this I squared is negative 1, so I've got 21 times negative 1 really, which gives me negative 21. Negative 4 minus 21 is going to give me negative 25, and I bring my 5i along. More foiling. So first, negative 3 times negative 7 is going to be 21. Outside, negative 3 times negative 5i plus 15i. Inside, I times negative 7, negative 7i. And last, I times negative 5, negative 5i squared. Again, my middle terms are like because my factors were in that a plus bi form. 15i minus 7i is going to be 8i, and this is going to be negative 5 times negative 1, which will give me positive 5. When I add 21 plus 5, I get 26, and bring my 8i along. This one's a little bit different because it's not just foiling. You'll notice this is the distributive property, so if I multiply 6 times negative 5i, I get negative 30i, and then I still need to deal with this 8 plus 8i. Still distributing. I'm going to distribute that. I'm going to distribute that. Negative 30i times 8 is going to be negative 240i, and negative 30i times 8i is going to be negative 240i squared. Again, that I squared is negative 1, so that gives us negative 240 times negative 1, which is actually positive 240. So we have negative 240i plus 240. I hope you realize what's wrong with this, and if you don't, look back up here. What order should it be in? This is the real part, so it should go first, and the imaginary part should come second. Now simplifying powers of I. In order to do this, whatever exponent you have, you're going to divide by 4. If you get a remainder of 0.25, your answer is going to be I. If you get a remainder of 0.5, your answer is going to be negative 1. If you get a remainder of 0.75, your answer is negative I. And if you get a whole number, your answer is going to be 1. So if I divide 20 by 4, I get 5. 5 is a whole number, so my answer here is 1. If I divide 17 by 4, I get 4.25. My remainder being 0.25 gives me an answer of I. 42 divided by 4 gives me 10.5. 0.5 gives me an answer of negative 1. And 35 divided by 4 gives me 8.75. 0.75 gives me an answer of negative I. Now to rationalize the denominator. Oh, the excitement. You probably don't remember, but in order to rationalize the denominator, we need to find what's called the complex conjugate of the denominator. So in order to find that, we just take the imaginary term and we change the sign in front of it. So our 3 stays the same, our negative 8i changes to positive 8i. And we have to multiply that, the numerator and the denominator, by that, so we're in essence multiplying by 1 and not changing our fraction. Now we get to FOIL in the numerator and the denominator. So negative 8 times 3 is negative 24. Negative 8 times 8i is going to be negative 64i. Negative 3 times 3 is negative 9i. And negative 3 times 8 is negative 24i squared. In the denominator, 3 times 3 is 9. 3 times 8i is 24i. Negative 8i times 3 is negative 24i. And negative 8i times 8i is negative 64i squared. Now we're going to combine any like terms. So I have my 24. Negative 64i minus 9i is going to give me negative 73i. Remember, my I squared is actually negative 1, so this is going to be negative 24 times negative 1, so positive 24. And in the denominator, look what happened. The reason why we use the complex conjugate is just so this will happen. See these two middle terms that just have an I? We cannot have any i's in the denominator, and if you'll look, one of them is positive and the other is negative, so they cancel. And remember, this I squared is negative 1, so all my i's in the denominator are gone. Negative 64 times negative 1 is positive 64. There are no longer any i's in my denominator, which is the whole reason for rationalizing this in the first place. Now if I combine like terms in the numerator, negative 24 plus 24 is going to give me 0, so I don't need to write that. I've got negative 73i over 9 plus 64 is also 73. Oh, and since this negative 73 over positive 73, I can simplify that and I would get negative 1i. On this next one, same thing, find the complex conjugate, so negative 8 plus 2i, multiply it, numerator and denominator. So when we FOIL that out, we are going to get 80 minus 20i minus 8i plus 2i squared over 64 minus 16i plus 16i minus 4i squared. Remember, these I squareds are actually negative 1s. So when we go down here, bring down my 80, combine my i's, negative 28i, 2 times negative 1, negative 2. Bring down the 64. These i's cancel like they should. Negative 4 times negative 1 is going to give me positive 4. So we've got 78 minus 28i all over 68. Now this didn't happen in the last one because I only had one term, but notice I have a real part and an imaginary part, so I need to split that up. 78 over 68 minus 28 over 68i. And notice I have all even numbers, so I can simplify that. This fraction can simplify to 39/34, and this one can simplify to 7/17i. We'll continue in the next video.